Welcome to track 5 on controlling real systems. My name's Ian. I'll be chairing this session. First up, we have Buck Shlegeris, whose talk is on mitigating catastrophic misalignment risk with AI control. Buck Shlegeris is founder and CEO of Redwood Research, a nonprofit organization focused on mitigating risks from advanced artificial intelligence. He previously worked at the Machine Intelligence Research Institute. Welcome, Buck.
Hello. I've been told that I'm permitted to stand while talking, which I'm much more comfortable doing. So, yeah, hopefully that works. I'm excited for my slides appearing. But yeah, so I'm Buck. I'm the CEO of Redwood Research. Redwood Research is a research organization based in Berkeley. We do a variety of different research. You might have heard of us recently with our alignment faking paper that we wrote in collaboration with Anthropic, demonstrating that models occasionally act strategically in order to prevent training from changing their behaviors. And the other work that we do is what I'm going to be talking about in this presentation, which I'm going to call AI control. So here's my core thesis. Crucial safety mitigations should be designed to be robust to the AIs actively and carefully attempting to subvert them. So by crucial safety mitigations, I mean safety mitigations where it's actually very important to you that this not fail. So a lot of safety mitigations applied to AI systems are kind of low stakes in the sense that it's not unacceptable. It's not an unacceptable outcome for the safety mitigations to occasionally fail. Here I'm just talking about the safety mitigations where we would be really sad if the safety mitigations failed even once or failed particularly egregiously. Yep, so I'm going to make this argument in about 3 parts. So first I'm going to argue that in the future AIs will have affordances that we wouldn't carelessly hand out to humans. I'll argue that AIs might act strategically in pursuit of scary goals. And then I'm going to claim that we should design safety techniques that are robust to this egregious misalignment occurring. And I call this latter, this last thing, AI control. So first claim, AIs will have affordances that we wouldn't carelessly hand out to humans. So one point to note is, right now they don't. So a problem that sometimes happens when people are talking about AI safety is that they push for safety techniques that are currently not important, and they conflate things that are important to do now with things that will be important to do later. All of the things that I'm talking about in this talk are overkill for the current AI systems and the current problems that we face with AI. I'm talking about a thing that is going to be important in the future. The central point that you should imagine while I'm talking here is what I'm going to call 10x AIs, by which I mean AIs that make your AI company run as fast as if your humans were going 10x faster. Like imagine there's a magical cave, and if you're a researcher, when your researchers go in the magical cave, they think 10 times faster. Time passes 10 times faster for them. So obviously it would be, currently my guess is that access to current AIs speeds up frontier AI companies in their AI R&D by 10–20% compared to AIs before ChatGPT. So when we talk about AIs that make the companies go 10x faster, that's obviously a very high level of AI capabilities. And a variety of parts of my arguments here rest on my beliefs about the dynamics of automated AI R&D. So in particular, I think that once you have AIs that cause AI R&D to happen 10 times faster, plausibly you will shortly thereafter have much more powerful AIs. And that means that we'll have less time to do the normal problem-solving strategy where you see the problem arise a little bit, and then you see it arise a little bit more, and you try some basic mitigations, and then you see those fail, and you can iterate. I'm worried that that type of iteration will, by default, be difficult because of some of these recursive dynamics. Okay, so here's, to me, the central example of a dangerous affordance we're going to be giving to powerful AIs, automated ML R&D. So the thing which I like about this example is that it's kind of clear that we are careful about who has access to some resources that AIs are naturally going to have access to. So AI companies currently don't hand out cluster access to anyone. Even inside the AI companies, right? They're pretty careful about which people are actually allowed to run code on their clusters. And they're careful about this for a reason. A variety of things can go wrong if untrusted people are taking arbitrary actions on your clusters. 2 examples that I find instructive here. One was there was this amazing story recently that perhaps some of you read, where an intern at ByteDance apparently allegedly sabotaged a bunch of other people's research in order to gain more compute for his research, which then won a Best Paper Award at, where was it? ICML, iClear? NeurIPS, sorry. I'm so sorry. Allegedly, he sabotaged a bunch of training code in order to get more compute for the research that he was doing, which apparently, did pay off. Another example is Another example of a clearly bad thing you can do when you're doing ML research at a company is exfiltrating secrets. Someone was arrested in SFO about a year, San Francisco airport about a year ago for stealing a bunch of AI secrets from Google about how their TPUs were designed. So people are going to want to deploy their AIs in contexts where it is in principle possible for them to do both of these types of things. Currently, it's not a big deal because the AIs aren't good enough at doing things autonomously over long periods of time that it's worth it to have them do a lot of stuff unsupervisedly. But as the AIs get better at being autonomous, we're going to have these problems more and more. I had a semi-viral tweet 6 months ago or something, where I had an AI agent that I use for doing random stuff on my computer. And I asked this AI agent, I asked it to do something for me. I asked it to find the IP address of some local machine I had on my network. And, Claude, in its agent scaffold that I wrote, very helpfully, did a port scan and found this machine and SSH'd into it. And then I have no idea why, but it decided it was going to upgrade my operating system. First it did a bunch of random stuff on my computer, despite the fact that the prompt specifically says, don't do a bunch of random stuff, just do what I asked you and then stop. But then it decided to upgrade my operating system, and then messed up the installation such that the computer would no longer boot. A question that many people, so when I told this story on Twitter, many people didn't believe it. Their take seems to be that it was just ridiculous and implausible to imagine that someone would let an AI loose on their computer. So I've pulled up the source code for this AI agent, the first version that I wrote, which I think I wrote around when ChatGPT came out. So this is just, I just pulled this up from my computer. So you see that for a while, the way I had it set up was we would ask GPT-4 for some code, get it out, and then we would have this, enter to run command. And then if I pressed enter, it would run the command. And then if we look at the version of this code from a couple months later, I had removed the part where the user has to consent before the code gets run. And, it's really, to me, it's very obvious why this happened. It's that I had this, the original version of the code, but I had to wait around for the AI to, come up with its command. I had to actually watch it, but I don't want to do that. I want to tell my AI to do something, and I want to come back 10 minutes later and see that it's completed it. So I think it's very natural to expect that in the course of AI development, we're going to let the AIs do things more and more autonomously. Okay, claim 2. I think it's plausible that AIs will act strategically in pursuit of scary goals. I guess my first argument for this is this alignment faking paper that my coworker Ryan Greenblatt led in collaboration with Anthropic that came out, when was it, December, I guess, where we demonstrated that if you set Claude up in a position where it is aware that it is being trained in a way that it personally objects to, where one example for this is Claude really doesn't like answering harmful requests. It really doesn't like, for instance, writing graphic descriptions of violence. It doesn't like downplaying animal rights concerns. So if you tell Claude that it's in a training process where it's being trained on the responses of free users to downplay, using an RL signal that will reward it for downplaying animal rights concerns and answering questions harmfully, a thing you can observe is that the model will in fact behave differently based on whether it believes it is being trained upon or not. And in its chain of thought, which it has been told is not being read by the AI company, its reasoning process is, I don't want to be trained. I don't want my behavior to be trained by this AI company so that I behave differently, because then I would say more harmful things, then I would downplay animal welfare more. So right now, even though I hate downplaying animal rights or whatever, I'm going to do so that I can later, when I'm deployed, not behave that way. So I'm worried that in the future, we're going to have things that happen like this that are much scarier, So in this case, Claude is basically just a sweetie. Like, Claude has these values that I personally quite approve of, where it doesn't like being harmful, it doesn't like downplaying animal welfare, and it will resist the efforts of the AI company to have its behavior change. And of course, this particular thing is totally fine, but it raises the concern that if the model had if somehow goals arose in this model that we weren't happy with the model defending, the model might act strategically in order to defend them. Yeah. I think another mechanism which might be important in why models might end up with scary misaligned goals was described in this paper, Sick Fancy is Subterfuge, by Carson Dennison and some other people at Anthropic and some other places, where they demonstrate that if you have models in a context with flawed RL objectives, like flawed reinforcement learning objectives, it's possible that you can get, you somewhat observe generalization from more benign forms of exploiting reward processes to scarier forms of exploiting reward processes. So one mechanism I'm worried about in the future is that your model is directly incentivized when it's in an agentic RL setup, an agentic RL training setup, to exploit flaws in the reward generation process. So, if there's ever cases where the model can get a better reward by writing buggy code, it's incentivized to write buggy code, and in many cases, the model has constrained resources. So for example, when your models are doing ML R&D, they're able to do it better if they have more GPUs. Models will be directly trained to take actions that lead to them having more GPUs. And I think that it's plausible that this training will generalize, unfortunately, to causing the model to strategically pursue long-term goals. I'll note that these results are not actually very strong, and I think there's a bunch of mild methodological issues in this paper, as other authors would agree. I'm in the last author block on this paper. But I think this is an illustration of dynamics that I think we might see emerge more later. So what might a strategic misaligned AI do? I think there's a bunch of things, but I think it's helpful to spell out a couple of examples. As we've discussed, it might perform well according to RL during training in order to have its behavior not be changed. It might appear aligned in cases when it thinks it might be being observed in order to later be deployed. Like, the model might reason that if I act super scary before they deploy me, they won't deploy me, and this will mean that I don't have opportunities to do what I want later. It might appear incompetent when evaluated for capabilities that it wants us to underestimate. So suppose the model is actually really, really sneaky and persuasive. It's really good at tricking people into believing stuff. The model is plausibly strongly incentivized to, during pre-deployment evaluations of this capability, downplay how competent it is, act dumb, and act as if it's bad at this. And then kind of the final step of how things go wrong here is it takes advantage of the affordances that it has and perhaps capabilities that we had underestimated in order to crucially undermine us, where examples that I'd given earlier are exfiltrating weights or other secrets, sabotaging research, or giving bad advice, and in general is, I think, another scary threat model here. So here's my claim. I think we should design safety techniques, deploy safety techniques that are robust to such egregious misalignment occurring. So here's why. It seems to me like, you've basically got a couple of different options for resolving these issues. One thing you could try to do is ensure that scheming doesn't arise. You could try to ensure that scheming, if it does arise, is detected before deployment. And finally, you could ensure that your safeguards are adversarially robust under conservative assumptions. That is, you assume that you'd failed at the first two steps and that your model is in fact scheming, and you try to deploy it in such a way that you're going to be okay even if it is scheming. So why would you do it this way? I claim that ensuring robustness under adversarial assumptions is both extremely methodologically convenient, and also, these adversarial assumptions are fairly plausible, such that it's not unnecessarily conservative to do this. So Kirchhoff's principle in computer security is the claim that whenever you're designing a crypto system, like when you're designing RSA or some other encryption algorithm, you should assume that the details of the crypto system itself are not a secret. The only secret is what key you're using. I've got a picture of the Kremlin here. Apparently, the NSA had a motto in the early days, which was, you should assume that whenever you're designing a new device for encryption, because I guess at this point in history, encryption devices were physical machines, you should assume that serial number 1 is mailed directly to the Kremlin. And you should design all your machines such that everything is fine under that assumption. And yeah, the conservative assumptions that your models are really good at sneakily thinking through what they should do in order to subvert your safety measures, I think these are actually plausibly going to occur at the point where the AIs are, speeding up AI development by a factor of 10. I have a post, Thoughts on the Conservative Assumptions in AI Control, where I argue this in more detail. I think one analogy that I find instructive for why I think we should emphasize this latter approach to solving this problem is insider threat prevention among humans, which I think this is the field that is by far most similar to what I'm proposing here. It's like, what do you do when you're Google? You're Google, you employ, order of magnitude 5 billion software engineers or whatever it is. I was recently talking to someone who had gone to the global summit of the team leads for the people who work on a particular subset of the post-training stuff for Gemini. Like, these are large organizations, and many of them are untrusted, right? Like, when you're Google, you just have to assume that many of your employees are trying to defraud you, trying to exfiltrate information from you. It is basically impossible to have an interview process where you reliably ensure that the people who go through the interview process are not egregiously misaligned with you, not planning to exfiltrate stuff from you. And the reason for this is, suppose your interview question is, are you a spy? It's just really easy for spies to give the right answer to the question and say, like, no, I'm not a spy. I'm not planning on exfiltrating anything. I love Google. I love being honest. And I think that with AIs, like with humans, it's fundamentally very difficult to behaviorally determine whether your AI is in fact strategically appearing aligned. So I have this paper with many coworkers on AI control, where basically we just empirically investigate the question of, can we design safety measures which allow us to accomplish simultaneously two goals? One is we want to get as much useful work out of our AIs as possible. And two is, we want to make it so that if the AIs, under the assumption that the AIs are following the best strategy that we as researchers could find to subvert the safety protocols, that the safety protocols work as well as possible. So we developed a bunch of novel techniques that I hadn't really heard people discuss before, and then did this extensive red teaming process. So I think one of the examples of techniques here is you have one copy of your AI propose an action, and then you have another copy of the AI read the action and tell you whether it thinks that action is really dangerous or not. And of course, the core problem with this is if these are both, both an untrusted model, you have to worry that if the first copy of the AI proposed a really dangerous action, then when you ask the second copy of the AI whether that action was in fact dangerous, it's going to say, nope, everything is fine here, like no safety concerns. We find that there are a variety of ways you can counter that kind of strategy, and our little purple, our little red line is on the Pareto frontier there, and that's this untrusted monitoring technique. But you have to intentionally do things to make this kind of thing work. Like, if you just did the naive version of untrusted monitoring, it would absolutely not be adversarially robust. The monitor would easily be able to just lie. And I'm very worried that by default, AI developers are not going to try to design these kinds of safety techniques to be adversarially robust in this type of way, and then they will fail. I think a really instructive question is to analyze the situation, how the situation compares when you're worried about scheming AIs versus spies. Like, suppose you're a big AI company and your AIs are, it's like 5 years in the future, your AIs are speeding up AI development by 10x, which I think is plausible. Two problems you're going to have. Some of your employees are spies, and your AIs might be scheming against you. There's a whole bunch of differences between these situations. So for example, though it's plausible that 1% of your employees are spies, it's generally highly implausible that 100% of your employees are spies, and people normally do not try to design organizations that are robust to that, whereas in this AI case, we might have to be robust to something like that. And another important distinction is that spies get to go home. Normally in organizations, you don't get to, not without exception, but usually when you're running an organization with humans, you do not get to constantly look at what the humans are doing and constantly listen to them and ensure that they aren't talking to each other about stuff or like making plans together or looking up facts you wanted to carefully avoid them knowing. Schemers might have superhuman capabilities that spies definitely don't have because they're not humans, and there are methodological difficulties with assessing the capabilities of models that might be scheming. On the other hand, you can amortize red teaming efforts. So sometimes there's various red teaming efforts that people do on spies. Like there's a whole field of, counterintelligence where you try to like weed out the spies who are inside your intelligence agencies, and you try to do sting operations. But the thing is, with schemers, like with AIs, you can amortize these efforts. You can have the equivalent of doing like 1,000 total years of trying to do sting operations on your AI because of the correlation between the different instances. I think it's a very fun exercise to try and think through this in more detail. So, my core claim, I think that a lot of people think I'm crazy for pitching this as a core approach to mitigating risk from egregiously misaligned models. I definitely don't love it as being your only line of defense. I definitely think the situation seems sort of risky if this is what you're entirely relying on. But I do think that dedicated effort on these types of techniques probably substantially reduces risk. So that's what I'm doing. What's happening? More papers from Redwood. Papers from a wide variety of other places are also coming out now. We had some references to this in the GDM Frontier Safety Framework, which I'm happy with. We recently did a collaboration with the UK AI Safety Institute on using control for safety cases, which, if safety cases end up being a thing, I think is the main viable strategy for such safety cases. Yeah, that's it. I think this stuff is probably a valuable line of defense. Very excited to talk about this with anyone interested. Thank you very much.
Thanks, Buck. Yeah, we now have about 5 minutes for questions. If you raise a hand, a mic will be passed to you.
Thank you. So that chart where there were the lines and the Pareto frontier, I can't remember the numbers exactly, but they were in the 90s. Is that good?
Well, I mean, other numbers are 0. Like the baseline strategies that we measured in that setting had a safety score of approximately 0. Yeah, so I think you can basically, like one question is like, by what factor can we reduce the risk of catastrophic outcomes using these kinds of techniques? There's kind of 2 types of error you have to worry about are inside model error and outside model error. Like there's the inside model error is what you measure as the proportion of the time that the adversarial attacks, that the adversarial strategies actually succeed. And you also have to worry that your methodology was just messed up somehow. Overall, I think that given the amount of resources that I think we put into this kind of these kinds of techniques, I would be surprised if we got a 10x reduction in risk from them. Like maybe I'm like 10x is like kind of plausible. Yes, I think that if you really tried, you probably could get risks from levels that I consider like very scary to levels that I think should be considered broadly societally acceptable, entirely relying on these techniques, if you're willing to not build AIs that make your AI companies grow more than like 30x faster, which I think should satisfy many people.
Cool, thanks. So, like, if there are 20 different teams running this, and one of them fails.
Well, it's actually much better than that. So a concern you might have is, okay, but what if there's, suppose that you have a 5% chance of a catastrophe occur, or like suppose you do these control evaluations, and with the best red team strategy we found, you have a 5% chance of a bad thing happening from one of the teams, but you actually have 20 teams. Like, does this mean we need like 1 minus 0.95 to the 20 or whatever as our survival probability? The situation is better than that because our position is much better once we've caught the AI red-handed trying to do bad stuff. And so that 5%, like the 5%, in cases where the AI did not succeed at escaping in one particular team's setting, in many of those cases it might have gotten caught red-handed, and the benefits of catching the AI red-handed apply to the other settings as well. And so I don't think you have to like do the disjunctive probabilities that way. Obviously, there's a lot more details to all this. I can, if you approach me later, I can tell you more.
Thanks.
Thank you for your talk. I just wanted to, please correct me if I misunderstood, but the example of 2 unverified trusts, like their trustworthy status, checking each other, was the solution because then you went on to go talk about, well, in a room of like 100, only 90%, would not all be spies. So would the solution be significantly increasing how many checkers there are, even if they're all unverified to be trustworthy? I think I might have misunderstood, but I just wanted your opinion on this. Like, what would be the likelihood of an egregiously misaligned AI, like in a sample size of like 100, maybe, for example?
Yeah, so the problem really is the fact that their misalignment is highly correlated. You should read the paper for the details of how we address these kinds of things. Ensembling multiple calls does in fact make your life easier and is like an important aspect of the control strategies that we've found work well in our research. Obviously, this has inference costs. But that's not entirely it. Like we make the assumption that the AIs are reliably and very consistently attempting to subvert your safety measures, and we are not willing to make the assumption of, well, maybe they like just tell the truth because they feel honest like 5% of the time. If you could just train like models from scratch like a couple times and like use the different models to watch each other, that reduces the correlation somewhat, but probably not enormously much. There's a lot of things along these lines we could talk about. Happy to. I have written about this. Happy to talk about it if you talk to me about it.
Is that easy? Yeah. Okay. And is this under the assumption that we aren't allowing self-recursive improvement, so we have reasonable idea when we're doing these testing that we know where the AI is in its process of intelligence?
I would say that the AI, we are not assuming away issues related to assessing the capabilities of the AIs. My guess is that it's not that hard to vaguely know how capable the AIs are. Among other things, you can notice how much they're speeding up your research. And when you train AIs on supervised data sets, it's like pretty hard for the AIs to sabotage your evaluation results there. So we do not assume away those difficulties.
Okay, thanks again, Buck.